Hello, welcome to my video tutorial. I am going to discuss about a priori algorithm in this tutorial. I am Pranav Arora. I am pursuing my master's in computer science and uh, I did my co-op with Canadian Blood Services as a software developer. In this tutorial, we will be talking about association rule learning, which has two algorithms, which is a priori algorithm and eclat. In this tutorial, we will talk about a priori algorithm. So you might have heard about or you might have seen on various e-commerce platforms or different movie rating websites about the association. Uh, it goes like this, customers who bought certain item also bought certain other items, like customers who bought a specific kind of book will also like some other books. Uh, so these all are the part of association rule based learning. Let's assume there are few transactions, and if we see that in the first transaction, the four items were bought, like item 1, item 2, item 3, item 4. Similarly, in second transaction, two items were bought. The third transaction, three items were bought, and so on. Based on this table, manually we can deduce some rules that people who are usually buying item 1 are also buying item 2, and people who are buying item 2 are also buying item 4. This is the gist of a priori algorithm. We will talk about more on a priori algorithm, but the final result or the final goal that a priori is trying to achieve is the set of rules uh, by which we can determine the likelihoodness of a person who will buy item 2 if they are buying item 1, and so on. So let's move on to the inductive bias of a priori algorithm. So the inductive bias of a priori algorithm states in its principle, which says that if an item set is infrequent, then all its supersets must also be infrequent. For example, if a burgers found to be infrequent in the item set, then we can expect that the superset of those item set which has burgers, fries and ketchup will also be infrequent. Now let's move on to the assumptions. So there are few assumptions in a priori. The first one is the binary representation of data. So either the data is there in the instance or it is not there. The another one is the fixed size item sets. It is kind of a hyperparameter as well, and we will discuss about it later. But it is the fixed number of item sets that we need to associate. Then the a priori principle itself, it reduces the search space because it removes all the infrequent item sets. The last one is the minimum support threshold, which we will talk about later, but there are certain number of thresholds related to the a priori principle concepts that we have to maintain, otherwise it will prove inefficient. Now there are three major concepts of a priori algorithm. The first one being support, confidence, and lift. We will take market basket optimization example to understand about these concepts, and later I will show you one demo example of market basket optimization. So let's talk about support. What is support? Let's say that there are 50 transactions or 50 customers, and out of 50 customers there were 5 customers who bought burgers. So the support for the burgers will be 5 divided by 50, which is 10%. Now another concept is confidence. Let's say that in this um, set of customers, 20 customers bought burgers, and out of those 20 customers, 4 of them bought fries. So the confidence will be 4 by 20, which is 20%. So in this case, 20% of the customers who ordered burgers also ordered French fries. The third one is the lift. The lift is the improvement in the likelihood that a person who orders burgers would also like to order fries. In this example, let's say there are 20 people who bought burgers and there are 6 people who bought fries. Some of them who bought fries have not bought burgers. So if we calculate the confidence of the people who bought burgers and also bought fries, that was 20%, as we saw from the last slide. It is the same, 4. The support of the fries is 6 by 50. So there are 6 people who bought fries, which is 12%. The lift is the ratio of these two, which is 1.67. So this states that if we recommend fries to an individual who is ordering a burger, the likelihood that the individual will buy fries is 1.67 times more than any individual who orders fries. Now let's combine all these three concepts and let's form an a priori algorithm. So in a priori algorithm, the first step is we set the minimum support and confidence threshold. So we will state that how much support and confidence we will need in our algorithm. Then we will take the subsets of the transactions and we will calculate the minimum support. Similarly, we will also calculate the confidence based on the rules. Finally, we will calculate their lift and sort the rules by their decreasing lift. This is the pseudocode. There are two types of item sets in this code. One is C, which is candidate item set. Another one is L, which is frequent item set. Now this set has to pass the threshold. So the minimum threshold that they have set is 50%. So in this, D is eliminated and now frequent item set is created. Now we will create the superset out of this item set and perform the same operation until we reach our desired number of item associations. Remember, we had K. Let's see the relationship of this ML approach with other ML approaches. So in association rule learning, there are two algorithms which are a priori and eclat. We have talked about it earlier. We saw in a priori that we have three concepts which are support, confidence, and lift. But in eclat, we have only support. There are following hyperparameters. One is minimum support threshold. We have seen it sets the minimum frequency of the occurrence of an item. There is minimum confidence threshold to generate the association rules. There is minimum lift threshold, which helps filter out the rules that are not significantly better than random chance. And the last is maximum length of the relation, which was K, which we saw in our previous pseudocode as well. However, there are some limitations in a priori algorithm. First one being the scalability issues. It is difficult to scale this algorithm as it is very computational costly. As you saw that even for the associations, it has to run several times in the database. There are memory requirements, and we saw the repeated database scans. Performance degradation of the large item sets. If we want to associate more item sets, then it will be inefficient. There are challenges with the high dimensional data as well. So if there will be more number of features, then it will prove to be inefficient. To overcome the limitations of a priori algorithm, the recent study has been done. The first one was enhanced candidate generation. They have also introduced a new data structure, which is L1 table, which is reducing the database scans. And also they have decreased the computational overhead by optimizing the candidate generation and transaction scanning. So if we see over here, they have improved the candidate item set as well as the frequent item set. This has reduced the database scans and improved the a priori algorithm. If you see in this graph, The blue one is the a priori algorithm, and with the increase in the number of transactions, the time increases. But in modified a priori algorithm, the time is not increasing as compared to the previous algorithm. Now let's see the sample application. So this is the sample application. I have downloaded the dataset from Kaggle. So we have read the dataset. So in this dataset, if we see, there are 7,500 rows. So pretty big dataset. There are the instances, which are the transactions. So let's say that the first transaction or the first customer bought these grocery items. We just create the dataset into the array so that we can feed this array into the a priori model. And this is the a priori model on the dataset. Now over here we are applying a priori, and we have given the rules. If you see that we have used minimum support, minimum confidence, minimum lift, minimum length, and maximum length as our hyperparameters. Now let's visualize the result. So if we see over here, um, with every relation, it has created the support, confidence, and the lift. Now we will just simply make the data frame out of it and sort the data frame with the maximum lift. This is our final result. So if we see over here that people who bought fromage blanc have also bought honey, and the lift for this is maximum. These are the references that I have used. Thank you.